I just want to make a quick announcement, which is I want to say thank you to all of the presenters today. It's a lot of work to put together these presentations, and we really appreciate it. I also want to say a big thank you to you guys. As part of the Houdini family, one of the things that I love so much about this family that we're all part of is how generous everyone is with sharing. You see it on the SideFX forums, you see it on OddForce, you see it on Facebook pages, you see it at presentations and in the videos, tutorials people create. It's just so freaking inspiring, and I love it. Thank you everyone who puts work into this community and shares and is generous. So I'd like to introduce Jeff Wagner, who's a senior technical consultant at SideFX, also a maple syrup farmer, one of our most brilliant production consultants. Everyone, we go to studios and visit you guys, and everyone clamors around Jeff to try to get 1 ounce of his vast knowledge of Houdini, and so it's always a pleasure to have him on stage talking about the latest stuff. So over to Jeff.
Hi, thank you, Chris. So thank you all for coming. It's been quite a ride in the last couple of years. A lot of releases, a lot of features, and forgive me if I slip up and mention the feature that's about to come up, or Bill, we're gonna have to cut that stuff out. Because as Kai probably acknowledges this as well, because we're access multiple builds all the time, and sometimes it gets pretty confusing, right? And then there's a part of us that goes, oh, why are they doing it that way? We're sitting on something that's really good. So it's always exciting for us to give you a snapshot of where we are. And hopefully that's what I'm going to be doing for the next hour, is giving you a snapshot of where we are inside of 17.0. And in some of the various areas of Houdini 17, we've been silently sneaking features in the areas of, for instance, Vellum. And also some things to do with, we're sort of sneaking in some muscle stuff and some other things on the side. So daily builds are always a good thing to use if you're an indie user at home or an apprentice user at home, just to see where we're going. And don't look to the docs for help yet. We're working on that. So I thought I'd start with the sneak peek from Houdini 17, because it is mostly character work. The character team inside of SideFX spills over into various different departments. There's the simulation department, of which Kai is a part of. And Kai's a part of other departments as well, which I cannot talk about. And then there's the actual character team per se. We do have a character team per se, and it's head by head engineer Ed Lamb, who has been with us since the Wild days, 2003, I think, and with him a couple other developers as well, including Derek Moser and Michiel Hedgel, and so Derek is a general developer who can span from DOPS to character to UI. He's just an all-around great developer, and Michiel is responsible for the FEM side of things, and yeah, he's the reason why cloth keeps on changing, and we may or may not have backwards compatibility. But I thought I'd show you the reel anyway, just to give you a snapshot where we were last fall. Is there sound? Yeah, let me go back again. Oh, what's old school? Oh, got it. Yeah, I thought it was HDMI audio. Here, I got my phone. This is HDMI audio. I mean, it's not HDMI. So let me take a look here. We'll get the audio. Yep, that's it. I'll just do the audio. Is it function? Oh, that's going to be loud. Let's try that. Take two. So I'd pretty much argue that every feature in that reel does relate in some way, shape, or form to doing character effects. So it's and it was no surprise to me that the first half to 2/3 was dedicated towards character tools, and you can really feel it inside of the company as well now as we get closer and closer to parts of the pipeline that aren't traditionally effects, and we are embracing character effects with open arms. And one of the areas in which we addressed character effects is with cloth, hair, soft bodies, and even grains. We've even shoved grains in there in the last minute. So Vellum is a true multi-solver. It's OpenGL accelerated with a really nice graceful fallback onto the CPU, especially when last night when you're recording videos and your PC graphic card decides to go AWOL because you were using a new feature in the next release that baked it. So it fell back gracefully to CPU, which means that all the videos that you're about to see that I did last night are running kind of pokey. So I do apologize for that. But the big thing, the big release for Houdini 17 obviously was the Vellum solver. A couple years in development, many of our top engineers on the fluid side working on building you first-hand cloth workflows, first-hand hair, all coupled together with grains and solids as well. And we continue to work on those tools right now and improving them, getting feedback from the customers, sometimes backporting some features in that aren't too destructive, and then holding on to the more destructive ones for the next major release, which we're pretty much on schedule. And Sarah Raffan, who's one of our in-house, she is one of our in-house TDs. She does a lot of animation for us. She does some flip books for us. She also is responsible for delivering, in this case, cloth tests. And she did a really good lesson on how she rigged this character dancing about a month ago in the office. Please watch it online. She covers a lot of the panel-based workflows, which we're seeing here. We must have added about 15 to 20 SOPs on top of the Vellum SOPs to support the new workflows. And I think Kai started something with the 3 inputs and outputs with the first solver in Houdini 16. They sort of caught on with the Vellum solver. And also the bullet solver. So the bullet solver is going to be brought much closer in line with a lot of these tools as well. So get used to the 3 inputs and 3 outputs because you're going to be inundated with them. Oh, and by the way, in this particular setup, it's very straightforward. The way Sarah approaches her panel or her workflow is basically rinse and repeat. She'll work on one panel and in a little network of SOPs, maybe 4 or 5 SOPs, and then she merges them together with another panel. And if you've seen Jeff Late's masterclass, he shows you how to, it's a bit clumsy right now, but he shows you how you can merge the Vellum cloth inputs in the two when you merge, as well as the constraint inputs, and then you bring in your collision input into the right input. How long would it take for us to build a digital asset to manage 2 merges internally? For me, maybe about a minute or 2. So it kind of begs the question, why don't we do that? So we'll see. We'll try and make these utility operators even more friendly to the 3 input, 3 output workflow. As well, Vellum, it really surprised us how quickly we were able, once the basic fundamental structure of Vellum was in place as a multiple solver, we really were only expecting to be shipping wires and cloth, to be honest. We were not going to be shipping the TET mesh support in the solid solver, and we were not going to support grains. But because of the structure of Vellum and the team that we have, they actually snuck that stuff in. And we were concerned that would it be fully functional? And the answer was, yeah. Grains is almost there, by the way. It's still, I think, the only out of the solver of all the other ones that we've deprecated, which is the wire solver and the cloth solver, probably the only 2 that I would not use moving forward at all. I've still used the grain solver if I wanted to tap into those really nice constraints that we've built around that. But over time, I can see them all merging into the single solver for sure. And here's another piece of work that was done inside of SideFX. This was an early test with Vellum. I think this test was done late summer, early fall. And a lot of the cloth garment pieces that are hung onto the soldier are actually not even constrained to the character. Some are, some aren't. And early tests had canteens flying all over the place. And we were able to, internally now we have the capability of generating really hard tests and being able to create situations that are more realistic instead of keep on using the pig head or the flippy. So now constraints. If we're dealing with Vellum, we're dealing with constraints. And constraints are the #1 way in which you load up your geometry with attributes. And as we all know, once you load up your geometry with attributes, you can modify the attributes. And it plays the same rules that we've been using with for the last couple of years. We're moving away, as you know, probably completely moved away from local variables. I can't remember the last time I've used a local variable in one of the older crusty SOPs. I'm using the new method, which is using attributes inherited into downstream nodes to do the work. And if you do that, Vellum will gracefully acknowledge that. And as I said, Kai probably gave the best description of the attribute varying versus static that I've seen so far. Thank you for that. That was good, because that's really critical to understand how those attributes evaluate in dynamic. And we use that to great effect. For instance, many of these setups are done inside of SOPs. And with SOPs, we all know prior to 17.0, if I were to modify the DOP constraint network, feeding into, oh, how did I do that? How do I get back? Oh, that's awesome. I control, yes, there we go. Yeah, I'm happy again. I don't know how I did that. My cursor's probably on the other screen now. Yay! I'll bring it back to the screen. So, so as we're moving forward, in previous releases, if we tried and animated the bullet constraint in SOPs, feeding in the DOPs, you're killing yourself, because we didn't use that workflow that Jeff Late and his team implemented for Vellum, and which is what Kai took advantage of as well. So now we're able to modify any attribute in the SOP network. So that means now we can start pulling out a lot of the functionality that was currently buried inside of DOPs for pure efficiency's sake, and now get them inside of SOPs. And now that we're using this mechanism to only dirty based on varying attributes, it allows us now to lightweight, much more lightweight, modify attributes in SOPs and bring them in. For instance, all the cloth attributes on that flag. Oh, what did I do? What was it, the last slide? Oh, we opened up the wrong slide deck. That would make sense. So, yeah, that would make absolute sense. So, let's see what I can do. Okay, oh yeah, files, recent files. If it was actually loaded. No, that's my temp one, right? So I'm going to do file open and open up from here. I do apologize. There we go. And that should be better. And I'll pick up where I left off. I cut off the slides prematurely. Oh, that's where my cursor is. So I'm going to start off, I think it's there. That's good enough. No, I want to go all the way to the top. Way up. Somebody called me the friendly green giant the other day. Sorry about that. The friendly green giant. So I wanted to start here. So getting back to merging all the various functionalities. So when we shipped Vellum, we had to make darn sure that if we were going to deprecate the wire solver on you and stop the use of the cloth solver and move to this much faster workflow, we had to make sure that all the attributes and functionality of the wire solver and the cloth solver fully made it over into the Vellum world. But by getting grains in, the team, Jeff Late, was able to put sleeping in as a general construct inside of all of the PVD solvers, or probably also the Vellum solvers. So now, how we get this, we added sleeping, I think, in the last week before we went go with the beta. So we were rapidly now able to port features from all the various different solvers that we brought into Vellum and quickly deliver on that. And so with the constraints, everything in Vellum is a constraint. And there's basically one key node that we work with. So this is a quick wiring network of that. So we have two nodes, a cloth and a collision node. And here we can do just simply define our cloth, and we have the three inputs. The middle input obviously is for constraints, and the right one is the collision data. And then we can put down a Vellum solver, or pardon me, a Vellum constraints, and then put down a Vellum solver. And the Vellum solver is got all the hooks in it, and then Vellum post-process. So this iconic chain is being used over and over and over again. And I'd argue that you can do almost all of your character work with the Vellum solver exposed inside of SOPs. Now the Vellum constraints, you can keep on layering more and more constraints onto your Vellum objects. For instance, you can define them as cloth, and then you can add other attributes, for instance, to make the internal, you can do internal crossbars. And then you can maybe use a different type of constraint on it again that might define it to be an area to be a bit rubbery or a bit stiffer. So you can go in there and you can change all the various different components of it. And you'll notice that we have a whole, you can see Vellum configure, there's about 4 of them or 5 of them that are wrappers around Vellum configure. And then we have Vellum constraints, Vellum drape, and then Vellum glue. And more specialized nodes like Vellum rest blend that you could use to fake your own plasticity, and Vellum stitch points, which is great for the panel workflow. Vellum struts, as I said before, is a wrapper around Vellum constraints. And then Vellum unpack, which is actually used for crowds. So with Vellum Unpack, we have a very, very fast way of unpacking Vellum agents to access the skins inside of DOPS, where we can now do collision against cloth and wires all in the same simulation pass, or do a subsequent pass very efficiently. And finally, Vellum weld point. So a lot of tools that just come with Vellum alone. Then there's a handful of other SOPs that are used to create the panels, to surface the panels. And probably the most useful SOP of all is the detangle SOP. And if you have not used the detangle SOP yet, by the way, it's a great tool for feathers. So I'll get into that a bit later. The detangle SOP is great for running on curved networks prior to running through the Vellum solver. So you see detangle and drape used quite frequently surrounding the Vellum solver. But this is the simple flag solve that Sarah did for that made the splash screen. Now, all kinds of ways of visualizing the attributes on the Vellum solver, solver SOP. So we can visualize bend angle, bend stress, bend ratio, bend distance, bend stress. So, and all very easily visualize that. The constraints themselves are spatial. So when you define a constraint such as this, there's really simple. You put down another Vellum constraint, and you can do a constraint if you have a middle mouse input to be constraint guides. You can, or other cloth objects based on groups. Most likely, it's going to be based on groups, or if you want a little wrangle snippet. And if the one group comes close to a target point on the other surface given a certain radius, which again is an attribute which can be modulated, you can now do really automatic type behaviors. So for the first time, we can define a constraint on a simulation object. And it'll have that constraint defined. And you can have another object that has a similar constraint defined. And if the two get close to each other, then they start behaving. So that means we can now start adding behaviors independently of the actual solver itself, all upstream. So that now gives us the opportunity to build assets and tools on top of the Vellum solver, which we really haven't taken too much advantage of yet, but we will in the future, I'm sure. And it opens up the door for a whole bunch of workflows. So we're well aware that you like building digital assets on top of our solver tools, and we had a tough time with DOPS finally refactoring it to the point where you can successfully build digital assets in there. We sort of knew that going into Vellum, so we made sure that it all worked quite nicely. This is some of the art that Scott Keating did. Amazing stuff showing the struts, and each one of those constraints are pretty much hard constraints with a distance, and then given over time, we simply dissolve the constraints. Now, some more specific cases, some recordings, and in this case, we're taking a look at how you can do fracturing and how you can do constraints. So wiring up the two objects together. And then we can specify some groups. So as I said before, it's all group-based. So now we can create pin groups on our original cloth. And then running that forward, we can now change the actual properties of our sphere. And so again, two completely independent objects that are working together, and we can define all their constraints independently. And now we can put down, I should wear my glasses because I'm used to And oh yeah, that's right. We're doing we're creating the pieces with another dedicated SOP. And then we can do the cloth constraints on top of that. And then the vellum and the vellum stitch. And it all works hand in hand because we designed all of these nodes to simply plug and play together, as Kai mentioned earlier. And it really does. It doesn't do it for me though. I mean, whenever I wire my vellum networks up, I always try to do edge cases, and I'm always having to do really weird things in my networks. But that's probably good for you because I want to do a whole bunch of volumes to see how far we can push this. If I open my folder, I think I have over 100 HIP files that's ready to go that I've been working on and testing for myself. Some more attributes are very important to do strain and stress. In this case, this is all done with the Vellum solver SOP. So this is so far all the work that we've seen with the character workflow is done with the Vellum solver SOP. So you can do a lot of, this is all pre-fractured workflow. When would I actually go inside of DOPS and start using the solver inside and stop using the Vellum solver SOP? That question gets asked a lot. It's when I want to do dynamic fracturing, or I want to do any dynamic work where I'm changing the game plan, I'm changing the rules, I'm changing the geometry. For instance, I'm birthing multiple Vellum objects. You're restricted from doing that inside the Vellum solver SOP. And there's some curious omissions on the Vellum solver SOP. We have wind, but we don't have wind noise. So if you want wind noise, you then have to have Houdini effects, because as I said, everything that we're doing now with the Vellum solver SOP allows us to use core. So if we are doing some of this work now inside of Houdini, and we want to do some wind on our work, we have to double click and there's a nice dive target, but now you're restricted to FX. Nothing's stopping you from unlocking that node, and simply, it's actually a pop wind DOP inside, and we just raised up some of the parameters. Nothing's stopping you from raising the remainder of the parameters to expose, even the snippet if you want. And then you can work forward on your own version of that tool. Actually, that's one of the first things I do show when I start sitting down and demoing Vellum. Some other things, constraints. So now we can get, how far can we push the Vellum solver? So in this particular example, this is one of the many example HIP files that I'd like to run through so that everybody, I'm sort of like work on the simple stuff, and then you can scale it massively. And if we understand how these things work together in the simple case, then we can use these building blocks to build really complex systems. In this case, we just have a wrangler that sets the strength based on a bounding box. And now that we wire that together, we can actually visualize the strengths, so really nice, so we know what we're dealing with. We can actually even see the attribute copy. As Kai said, attribute copy is now a very important tool in order to clearly define what's dynamic and what's not dynamic. So you're going to see a lot more of this workflow in the many SOPs the many networks that I'm be building. And then we go to Vellum cloth, and then we do a pin to target. So this pin to target's really cool. It's another Vellum constraint, and again, I can specifically define points here, or I can use a group. And in this case, I'm using a group, and you can see the pin strength attribute there that I'm working with. And then I go into the Vellum solver, and I can actually change so you can see the attribute that I'm picking up, which is pin stretch, which is defined in the attribute SOP way up above, and then I can run the Vellum solver. So where am I getting these attributes from? Sometimes my cheat sheet, believe it or not, my cheat sheet is to go inside of DOPS and put down a Vellum. There's a specific DOP for doing Vellum, changing all the Vellum attributes, and that has all the attribute names that you can override. That's my cheat sheet. Or you can go to the help. I just go into DOP network and put down that specific DOP that allows the Vellum configure DOP, I believe. And it has all the attributes by name. And if you dive inside of it, if you're not aware of this, please be. The snippet VOP that's buried inside of every node that has the wrangler exposed has parameters inside of it with the names. And those parameters are what we drive into the snippet as arguments. And that we expose those arguments automatically in the snippet box at the very top. So you can actually write directly to those parameters. So that's something that everybody should know about anyway. So that's what we're taking about it. So if I want to see what the attributes are, I just dive into DOPS, and I have the Vellum configured DOP. Now in this particular case, this is another great example. We grabbed from a lot of the tests that would happen during the beta and internal tests as well. In this case, this was a pretty nice test. It broke Vellum pretty bad, so it's a really good case to show you what it can do, which is basically creating constraints that release on as the simulation runs. And you'll notice that the arguments are not contained inside of SOPs, and you're not actually seeing a Vellum solver in here. And I believe for this one we dive in, or yeah, we do have the Vellum solver, that's good. So we have the Vellum constraints, and we set the second Vellum to pins. And again, we're just setting we're setting a target weight as a wrangler, and we're just using the group called pins to pin the torus to the second constraint object that's coming in, and we can actually just use an output group called target pin in there. And an attribute wrangle, we do the target weight. Oh, actually, this is using the DOPNet, because we're on the edge now of what can you do with the Vellum solver SOP and what you have to do for DOPs. So in this case, I think I decided to just do it in the Vellum solver, make life a bit easier. And here, this is the Vellum constraints property DOP. That's my cheat sheet. If I hover over that, you can see that stiffness attribute. That's the attribute I can put in my geometry at the top and play with. So if you want to get your cheat sheet, it's right there. And we do fit at frame 1540, 130, 0. Everybody should know fit. And then there you go. So we're just basically releasing the constraints from frame 15 to 30 over time. And we are now setting up a lot more of the properties in here as well. Now this is where it gets a bit confusing. I'm going to let this play and then talk a bit about some of the things that might be confusing to this new world of working. Is that we have two places where we can create attributes. And when we shipped 17.0, I visited a customer in Toronto, and I thought everybody would be sort of happy with this, but they beat me up. And the reason why is they said, "Why are you doing things in SOPs now? You finally got us doing everything in DOPs. Now why is this duality?" And then I had to explain, I think there's a really good reason to do this, is if we can actually create SOP objects, as I was mentioning before, that were standalone with all of their attributes. And then go into the DOP network, and you just do a Vellum configure properties DOP, and then you can change or just globally modify those properties. And if you really, really have to, and you can put a snippet in there. And it uses all the POP tools, because remember, Vellum is a position-based solver. So at the end of the day, it's just points with edges. And only a couple of the solvers were considered surfaces within the solver itself, sort of, which is the solid solver and the cloth solver. So I have a file that I want to cover maybe in a future session or in another video, where how do you get other solvers to work with Vellum? And the answer is make sure that there's points, edges, and surfaces in those other objects that perform the same duty that a collision node would perform inside of here. So here's some more constraints. This time we're adding a really stiff bend constraint on this. We're still using cloth, but we're now using plasticity. But we're using it in a very interesting way. We're actually going to be setting the plasticity inside of DOP. So we're not allowing the solver to dynamically create it. What's the deformation change? Because sometimes you're in the heat of it and you got to deliver a shot, and you got to be exact as to when you want the plasticity to kick in. So in this particular case, we've now brought everything into DOPs. And we just simply have, we're exposing the attributes right inside of the wranglers now, geometry wrangles. And the one on the left is generating the attributes that we need to do the constraints, and the other one is getting keyframed to enable both of these solvers. The one basically sets the constraint stiffness to 0 or infinity, and the other one basically gets rid of the constraints themselves. And when we run it at frame 50, it's good. Oh yeah, thank you. And then it goes hard, and then it falls down. So really nice example file. I will be releasing all these example files, and they'll be much better commented. Help from Louis Dunleavy. Some of the early tests with feathers. I love it. I've been doing helping with feathers anyway since Valiant and Vanguard. Even earlier than that, the first set of feathers I know is right here, done in London by Framestore CFC back in the day for the Harry Potter Phoenix. That was first done with Houdini feathers, pretty cool. So I'm not new to feathers, been around the bush with them. I think Kai's also done a couple setups, and I've seen quite a few setups. But there's a couple new tools here to bring to the table, and I wish I could have had them last year for the presenters this morning. The first one is the Vellum, or pardon me, not the Vellum, it's the intersect, what is that one? I always forget it. The one that does the intersection test. Detangle, thank you, I mentioned it earlier. So detangle, we can actually, when we lay out our feathers and so there's two things you need to do. And I would probably use polyframe. SOP. The polyframe can use UVs, and if you've got a special UV map to lay out the direction of your feathers, you can actually use the polyframe to build a frame of reference based on your UVs, step 1. Make sure your UVs are going in the direction in which you want to lay your feathers. Step 2, you scatter your points based on UVs, and guess what? We even scatter them in the order that the UVs are being fired. So you can actually use that point ID to pass into the class onto the feather, because the third step is the detangle SOP can actually use those IDs to determine what order to do the cards. So even if it comes in with the cards somewhat intersecting, you can, with enough iterations, you can get the cards to at least start in a really good spot. By the way, it also works with the wires. And the only problem with detangle is if you want to do iterative detangling, you have to use a for each loop around it. Nice thing about it is you can use compile blocks because everything's compile safe. So and once you do that, then you can run it inside the Vellum solver as just cards. So this is just one of the early tests, and it just works really fast, really brilliantly, really nice. And I've done a couple tests internally for myself as well, and it works very well. So Vellum for feathers, I think, is a great foundation to build some more robust tools. Oh, and to answer the question, how would I do wires? I actually worked with the intern quite a lot at the early part of his workflow, and then he did a great job with the feathers. I would probably go spline-based. I probably wouldn't even use cards. I would use a surface to determine the orientation of the barbs that feed off the main wire, and just render the whole mess as wires. So in this one, I'll go back up and back down again. So this is a really cool test. It's basically pinning hair or fibers to cloth, and it's very simple setup. Again, this one is using the SOP solver again, so it's quite handy for us. We have a simple grid, and of course groups are our friend. In this case, we just use a simple expression to create a group for the cloth pins. And so I'm always using groups to configure stuff these days, or wranglers using the at group nomenclature inside of there. And then you can blast your points, and then you can use a copy to points. So it's still beholden on you to build up your systems. You know, how do you want to configure your geometry? It's still SOPs. Nothing's changed there. But now we actually have a really nice way of marrying the two together using those groups as a way of binding the relationships together. And here we're just adding some forces to with the guide process on the wires, then we merge the two together. And we're pretty good here because we don't have any constraint data that we're working with. We're still doing attributes, so we can freely merge the two cloth panels together. And then the relationship constraints we add are the ones that are adding the actual constraints for the cloth themselves. And then the second relationship constraint does the actual pinning. So, it's the constraints for the hair. So we do the constraints for the cloth, constraints for the hair, and then finally we add the constraints for the welding. So I always approach my Vellum constraints this way when I'm merging multiple cloths. I think Jeff Lake did a master class where he was doing the panel approach, and he defined all the cloth attributes on the geometry prior. I think I did that prior knowing to that, and I think I did it this way, and I still do it this way for now until I build that digital asset. So, but anyway, there's the Vellum solver working away on the various attributes. You can see here, I've been sort of glancing over substeps and how to set those substeps up. Substeps of 1 is far too aggressive for the majority of the work that we're doing, but we have to put it there for unit tests. You know, there's other solvers out there that have very simplistic unit tests as well, so in order to compare nicely on first drop, it's there. So be expected to crank up your substeps at least to 2, 3, or 4, 5, and your collision passes up to 20 if you have to. And we're going to come up to a really hard case next. And at least the feedback is fast enough. And by the way, this is when my OpenGL card blew out, so I was doing some other tests. So, but anyway, now balloons. So I want to cover balloon. I'm going to do balloons, advanced balloons. Like, how far can you push this constraint that we have that allows you to do inflation, and how can you work with it, and how does it play with other constraint types? And I've done a lot of work with balloons. This is a really early test from one of our testers that I really liked. So in this case, we're just, and this is a hack file, by the way. There's nothing procedural about it, so I didn't build it. But we're simply just radial lines, and we just accidentally put the balloons in roughly the right place. You'll see in a minute, we just do a radial copy on the balloon, so they kind of approximate based on the wire curves. This is like an anti-Jeff file. But testers, I love it. There's no wrong way to do anything in Houdini. I love this, right? I'm going, how, cruft in, cruft out, right? So it's awesome. It works. And so now we just radially spray the balloons around. But the constraints, the way our constraints work between the wire and the cloth, and the strategy does matter. So you're thinking, what takes precedence? And here it would be the wires. So you notice the wires are always wired in first. The wires are the ones that we're constraining to the balloons. And the way we constrain is they have a point on the wire, and we can just find the nearest face on the balloon. And then we can gracefully put that point onto the face, or we can snap it immediately, and that's generally the way it works. So as long as the balloons are in the proximity of the endpoints of those curves, we're going to get a constraint, a successful constraint. Remember I said I could have actually had the balloons very far away and then bring them in, and all of a sudden they'll snap because they're within that radial tolerance that I talked about, and then they'll be hooked up to those lines. And here we're just doing some more work about adding some air going up, and so we're basically adding some gravity, a wind force for the balloons going up. And again, you can see the solver parameters here. Substeps are 3, nothing obscene. Collision passes are 3, so we're not expecting to have too many inter-collisions or too many stacked collisions at all. And then these are all the various constraints. And this one I'm bringing inside of the Vellum solver for no reason other than this was a very early test before I even think we had the Vellum SOP done yet. But this one could more than easily be done in the Vellum SOP. Now for panel approach. So this came about as one of the 2 things that we wanted to deliver on inside of Vellum was cloth and hair. And I have some tests. I wasn't ready last night to do it, but actually some really cool tests where I actually have a hairy character with cloth on top of it, and then I put harnesses that span the cloth and the hair. Yes, you can do that. And yes, it's very well behaved, sort of. Sometimes the hair will chatter, but then you can detect chattering hair, and then you can damp it. So like all the games. And I have to say at this point in time, I missed the spring sop. The spring sop was supposed to be our general deformer and supposed to grow up, but it was dead for many, many years. The Vellum solver is now my generalized solver that I'm going to be using from everything moving forward. For instance, having a snake slithering over rocks and having the snake interact with the rock, I'm probably going to be using the detangle sop for that, and maybe some Vellum passes on top of that if a 4H loop gets a little bit out of hand. So this Vellum solver is now our general skin deformer. If I want to add just a little bit of jiggliness on my bear that's walking, and I want the jiggle to happen in its own space, I could use a polyframe to find a local frame of reference, and then make a jiggle on only the one plane and not the third plane, so I can get some really nice movement. You can do all of that stuff with the Vellum solver. It's a really handy solver. Oh, and the big thing about this one is, watch the videos from Jeff Wright and Sarah. All I'm doing here is I'm timing a third constraint to snap the front of the cloth when it gets close at a specific frame in time. And then I have a keyframe activation of that to slowly knit that together, and there's your keyframe. I'm using the new character tools, yay, which if I have time we'll actually cover a bit. But yeah, so there you go. So that's the frame at which we're snapping the guides together. This one's cool. This was an early test from one of our testers, and so Jeff Late said, or John Lynch or Jeff or one of the architects said, we've now added orientation along the curves as well, because that's one of the features of the wire solver, is we can have an orientation attribute. We can use a frame of reference. And this is what happens when you finally dial in your solver. The solver steps are pretty high. I think I had to go as high as 50 steps. And about 50 constraints. But anyway, you can see here what we're doing. We're generating 2 pin constraints, and then we just animate the 1 pin on the line moving forward. And we turn it into Vellum hair, and you can see here the tolerance, the thing. It's all defaults, right? Except for, we just added a pin group, which is the group above, which is the 2 endpoints. And I think it did the orientation pin type as none, and if you do match animation, the pin won't animate. So, and then later on we animate the pin. So here we can visualize the orientation attribute that we've added to the curve. And then finally we animate the first point. And as you all know, and this is the beauty of Houdini, right? You animate any point with any of our SOPs, and we take it for granted that the attributes are all going to be transformed correctly. And yeah, we do. So it's a cool system to play around with. We don't have any of the housekeeping you have to do in other systems. So now we're running the solver and the points moving in, and you go, yeah, Yeah, what's the big deal? The answer is, as it's coiling, we're adding a strain, an angular strain along, or pardon me, a radial strain along the curve. And as we change it from same as position, in other words, we change the orientation pin type now to take into account that angular twist. Now you can see that twist that we're injecting in that animated point is now being transferred across the whole line. And this is a really cool trick if you want to do hair and you want to create the curly cues, and if you want to have more of a natural look to it, like somebody twisting their hair all the time, there you go. And so I've done that to create really cool natural fiber curly cues as well, if you want to have more of a natural look, or you want to do something like that. That's pretty cool. So the very fact we're able to do this was pretty interesting, right? Wow. If but again, you have to go to the Vellum solver, and you can see here, I'm going to scroll up and you'll see, only 10 substeps? Oh, I only had 10. That's awesome. And 20 collision passes and 10 point collision passes. So you do have to play with the solver substeps and the collision passes and the post-collision passes. Post-collision passes, by the way, is the detangle SOP wrapped into the post-process of every Vellum, and now you can start doing that. And I'm sure if I up the substeps a bit higher and a bit more of the collision passes, it'll even be a lot neater. But this is really interesting what we can do when we manage all. And if I reduce them down, you'll see what my first test looked like, which was pretty nasty. You're going to get interpenetration, you're going to get things moving in and out. So this is just a lesson in managing your solver attributes, so make sure you do the right thing. And it's just the skin SOP that's failing up there. If I just do a higher resampling rate, I won't get that twisting. So then you set it back and you're happy. So there you go. Here's another test that Jeff Late did of coiling ropes. You'll notice that he has created the orient attribute on the wires. And you'll notice how you're naturally getting all of that curling and the strain and the effect of that strain along the ropes as well inside of the Vellum solver. So as I said before, I've got over 100 files that cover all the little minute features inside of all of this stuff. I watch carefully on our internal Slack channel. Every time there's a new feature, I'll just go off that night and build another file, and then I forget about it. And then I remember it when I have to do one of these presentations, and you go, oh, that's cool. So this is, again, another thing. Now, I would imagine that the substeps are probably around where I had them, 5, 10, 15, and the collision passes are probably going to be around 10, 15, 20, and the post-detangle passes might be in as high as 10 to get this to go stable. But the very fact we can do these really cool complex type simulations inside of the Vellum solver is just awesome. Ropes and braids. I sometimes get the question, well, what about interpenetrating cloth inside of Vellum? Well, this is where we borrowed a lot from the strategies that were used inside of the cloth solver, the FEM solver. So that's not a very good result. But here's another result of using Vellum cloth and type of a character that is brutally doing some interpenetration. And it's a bit better. I think I got the wrong movie. But anyway, I got the wrong movie. It should be much better. So the answer is, in the Vellum solver, on the visualization tab, we actually have one visualization option that allows us to see points that have interpenetrated. And what we do is we simply turn them off. That's what we do in the FEM solver. We just simply turn them off, and we just let them go where the forces take them. And then once they get into a position where they're no longer penetrating the surface, we gracefully bring them back into the solver. And obviously I got the wrong movie here because we should see it gracefully going down. Oh well. But anyway, more tests on. So the one problem we have with Vellum and cloth. Yeah. So if one of the problems we have with cloth is if we change the resolution, we get a completely different sim. So we built in some tools that allow us to do retargeting of cloth as well. So you can do a lower resolution cloth on the left and then drive either a mid or high resolution cloth as well. So so there are strategies to allow you to work with very low resolution cloths and then resend them as targets to the higher cloth. And finally, plasticity, a very important feature. Great for lion manes, by the way. You know, for instance, if you pet a lion mane, or if you get some fur that goes by some trees or some other Vellum objects, or even bullet objects. I said I can get this thing to work with bullet, flip, as well as pyro, both interacting. So there's ways to get this to go. And plasticity. So this is more plasticity. This is one just using a bend constraint when the hair bends beyond a certain threshold, or basically deforms beyond a certain threshold. I believe we use pretty much the same threshold algorithm that the current FEM solver uses. So we're trying to be somewhat common, and it works quite well. And of course that works on hair, grooms, and cloth as well. And Kai did a great job on Vellum hair, so I think I'm going to sort of pass on this to a great extent. Other than, I do want to say this. I've been using Kai's hair since 16.0. And 16.5, we added the partition for workflow. And that's something that we really need. I need to show how I do my partitioned grooms. For instance, those little eyes, if I'm working on every single individual groom patch on any character that I do, I'll first create a group for that. And then with Kai's great work that he did in 16.5 and now 17 with the accelerated workflows, I will work that groom on that nose independently from everything else to death. And then I simply will merge it with the other grooms I do. And at the very end, if I want to add a bit more detail along the back, I'll just grab the group, create another group on my original skin, and then create yet another vellum layer. So with many of my grooms, I maybe have 15, 20, 25 layer grooms. And I like to do all of my work at the object level. I will even use wind at the object level to try and get the hair to go in the right direction before I even go in and start merging them and start actually painting the guide curves as well, or using the volumetric tools to sculpt the hair. So there's some fantastic approaches you can do for fur, and you can get really, really far along even before you do a single brush stroke. Oh, again, this is detangling as well, quite nice. And a lot of hair tests. So Kai mentioned we don't have the best long hair tests or best long hair tools. I think we got a lot. I think that there's enough in there that us users can hack away what it is that we need. We don't have any polished tools, and I believe that's what Kai said. Is when we do a tool, this is the new SideFX. When we do a tool, we want to make sure that it's polished and it works at the artist level as well as the technical level. But we have lots of long hair tests. This is some internal tests that we did, showing you the various different effects between using clumping, self-collisions, and without self-collision, so you can see you get different sort of behaviors as well. And wet fur. So many different strategies to doing wet fur. In this case, I think you're blending between two different grooms, right? Oh, I got 2 minutes. Oh, well. And I'm going to see if I can go real quick. Soft bodies, finally. As I said, we did the tets, so we support tets. And we also support struts. So we've got some really cool stuff with struts as well. So pressurized soft bodies. And pressurized soft bodies. Remember those dynamic loop constraints, right? We can now add properties to all of our simulation, to all our objects that go into the simulation that have automatic behaviors. And tetrahedral soft bodies. A bit slower, but of course they're a lot more accurate, because the strain forces are now traversing edges and points inside of the body of it as well. And branching hair. So that's a specialized type of constraint whereby you just need a curve network, fuse the points, and you're good to go. And we can paint attributes as well. In this case, we can paint attributes for collision attributes on the geometry Scott showed that file. I'm going to pass that. I want to finish off with muscle and flesh. We've had this. This is like the saga of muscles inside of Houdini. It seems like every release from 16, 65, 17, we have different states of muscles. In 17, I believe the state of the muscles is now we're using sculpted muscles, where we can do unrestricted shapes and connection points. You can sculpt your muscles in another application. You can even deform them in another application, bring them in as either Alembic or FBX, and then you can pass them in through the FEM solver. And I'm not going to tell you what kind of muscles those are. And so this is a test in 17.0 before the team hunkered down and started refactoring everything for the next release. So hopefully very soon we'll have a coordinated set of muscle tools that are fully featured and ready to support in hard production. You can use the muscles today if you want, though, and the results will vary, but for the most part they'll be pretty good. So, and as I said, you import the muscles as a cached FBX or Alembic, and then you use the new tissue solver assets to solve your final skin. And this is another dinosaur test. And wrinkling. So we even support wrinkling on the FEM solver as a post-process as well. We introduced that in 16.5. Yep. And grains. I'm going to pass the grains because, it's pretty simple. Characters walking through sand and walking through thing. And the character toolkit. As I said before, we have a whole bunch of engineers that the end game is most likely, if you start using more and more character effects inside of Houdini, at some point in time you're going to have to animate in Houdini. So just to let you know, we are working very hard on animation, and 17.0 sees us refactoring the entire play bar. You can go to the preferences and set either the small play bar or the large play bar, and refactoring all the animation tools. It's trivial now for me to add keys and use soft modular like middle mouse buttons to move keys around, so it's really, really cool. And more rig controls as well. So we are working very hard on rigging. As I said, Sarah does a lot of animations in-house for us, and we get some really nice, sometimes we get interns that can animate as well. And we have really nice post-based deformation tools that we added as well. So, and that's it. Yep. So I can keep on going on. I can keep on going on and on. Let's see what else that I have there. I had crowds, but somebody else is covering crowds today. And as I said before, we have lots of opportunity to, I'll end it off here because there's some really cool stuff we're doing with auto rigs. And internally right now using that, and oh, I'll just quit. So,
any questions?
Any questions?
Over there, Paul.
Thank you. So for designing the cloth and the draping, are we going to have much more control like in Marvelous Designer where we can just click and drag the cloth to adjust the stretchiness and stuff like this?
There is a quasi-state mode in the Vellum solver, because quasi-state, what that means is solve at the current frame. The drape solver has quasi-state exposed. So one of the examples I want to run through with Chris, and really soon to have a loom, I hope, is put a cape on a character and then run that character through several shots and show you different strategies to pose that cape, that an animator could pose that cape at the start frame, right, and then release it. So that's the sort of things we want to be able to do first out of the box, and that's what we can do right now. As we move forward, yeah, we want to give you even more direct manipulation and control of the cloth, and not have any of the restrictions that you would have in other solutions, for sure. And as I said before, we can right now pose cloth leading into a shot. So if you had to pose your cape, you could either model it or you could use it with a drape solver, pretty much interactively if it was a low enough resolution, and then go, yeah. So we are definitely looking at that. The panel workflow it's there. We got a couple master classes on it that shows you how to do it, but it's still early days. It's our first shot. Okay.
Thanks.
Yep.
When talking about the lion, you said you could go a long way without even using a brush stroke when it
Yes.
comes to combing the fur.
Yep.
I was wondering what are the ways you usually do besides the wind?
Oh, so you basically have a subset of all of the parameters that you get with the Vellum. What is the Vellum? I forget what what's the main fur tool that we always use? The main SOP for doing all the frizz and the sculpting. Yeah, the guide process. I'm so sorry. Yeah, the guide process. A lot of those parameters are raised to the top. So once they're raised at the top, you can actually do a lot of work. And if I have to go in there and add a guide process or add some wind right in there, I'll do that as well. But I don't. I just keep it at a very top level when I'm doing my first pass. And for instance, the frizz in the line main, I just basically blow wind, and then I just add some frizz. Good enough. Let's move on. Let's start working on the rest of the line. And literally, in about half an hour, I could have the entire line blocked out with all the different fur pieces in place. Then do the cycle of death, right, until you finally get what it is that you want. Thank you. Cool.
Could you give some examples for Vellum for crowds? Or
Oh, I
talk about
didn't
that?
get to that. And guess what the next slide is? Oh, that's pose-based deformation. Crowds. So, as I said before, we did a lot of work in Vellum for crowds. This is great work done by Cameron. We now have a way of quickly unpacking the skins for the agents, and then we solve the hair directly against the final surface right inside the solver quite efficiently. So that opens up the whole door for doing these sorts of simulations as well. And you can see the various times. So you can do your crowd sim first and cache that off into data on disk, and then bring that in and solve your hair, or you can actually do it in a staged DOP simulation, whatever it is that you want to do, or both in combination. So yeah, so it's all set up, ready to go. So we just, if you use the shelf tool to set it up, it'll behave nicely. We actually have a new crowd default, I think, the very last one, that actually shows you how to do that as well. The setup for that.
I know there's some more questions, but we have to move on to our friends at Axis. Jeff could easily spend the entire afternoon talking, and I know that that would be awesome, but we'll have to do that another time.
There's more crowd stuff. Yeah. So I was ready for it.
See what I mean?
Bye.
Thank you.